Test. Alright, hello. We are going to continue working on joint physics for the physics engine in the game engine. Right now it's way too elasticy. I went back to the elastic model to do some testing. Still not happy with it, but I have some ideas. The first thing I did was I tried moving the positions along the velocity into the future by the delta time, and I found out doing that by a scale of 10 actually pulls them together much more, very much like the other technique I was using. Actually, it doesn't work here. I need to turn up the joint strength. Maybe if I do it like this. Ooh, 1 second. Alright, I know why that's not working. It's because this is supposed to be multiplied by dexp instead of delta time. Alright, times 100 is too much. Times 10 though, you can see they stay together way more, but it really slows down the movement, which is really bad. So instead, what I'm going to look at doing is doing the difference in velocity as well as the difference in direction. So yeah, I don't think I'm going to multiply. I'm just going to start rewriting this. I don't know why, but I find it so much easier to just like start rewriting the code sometimes than refactor the existing code into what I want, even if the code is super similar. Alright, so then I might just actually operate straight on the velocities. Oh yeah, I was also thinking of another technique where I could use a really high joint strength here. I just need to limit the velocity to what it's supposed to be here. Like, for example, if the max velocity it needs to connect these, it's like 0.5 or something, then it's going to match that. It's a really stupid example, but let me try programming that. So what I need to do that is I need to calculate. Wait, I'm an idiot. So if this is the difference in the position, that's what the velocity actually needs to be. Oh yeah, minus joint radius How would I even do that? Clamping a vector of the same direction. I don't want to clamp it unless it's going this direction. Nah, that seems like a stupid approach as well. Alright, I can still try doing the difference of the velocity. So LA is going to be lerp amount, because that's what this is lerping. It's calculating the difference here in the two variables and then scaling them by that lerp value. So the max lerp value should be 0.5 because that's what it needs to match. Bring each of these particles or connected bodies together. Also, make sure viscosity's off. Yep, okay. So that's really interesting. A bunch of them stayed together and then at the same time they completely fell apart. Let's try a higher lerp value. Yeah, so that's really bad. It's not bringing them together at all. Yeah, so it ends up subtracting the y from here. Yeah, so that won't work. Oh! I think I was kind of getting it before with limiting it. So it's not limiting it, it's stopping it from colliding through the connected joint is what it is. So if the velocity is so high that it'll fly through the connection point. So actually no, this should be like a maybe a dot product. Well, dot product would be used to calculate the line. Actually, no, that's still not good because it should gain the velocity and then it should collide with it and transfer that velocity Yeah, this whole approach just isn't good. I'm thinking of setting up, I might build the little race car example now because, or at least a little thing where I can control these. Yeah, actually maybe just this, I'll just give myself, I'll add little keyboard controls so that pressing left and right will bring it back and forth. This looks pretty good. My issue is I hate how the spring joints can stretch so much, leaving gaps between them. And yet this doesn't take mass into account. Actually, let me see if I can do mass with this spring joint. Oh wow, that works. You can see it's way heavier down there. So then let me try increasing the mass to 10. You know what? These spring joints might work. Oh god, yeah. So I don't think that's how it's supposed to work. Okay. I gotta figure out another way to do this. This spring joint might work well if I can actually get this mass into the calculation. I think maybe limiting this to 1. Limiting each of these to 1. Well, that actually seems to work pretty well. I'm intrigued. Let me try lowering the viscosity and see what the effect is. Yeah, it's acting heavy. Let me try lowering the joint strength, and maybe even changing the joint strength for each of these. So yeah, I think I need to increase the joint strength up here. Oh my god, this is actually really good, I think. Okay, I'm gonna try building... Oh god. I'm gonna try building the car example. Okay, so super interesting thing about this too, that I just realized I could actually account for this elasticity by calculating the distance between them. So this approach right here is super good. If you see, the distance between them basically stays equal. And so I can calculate the distance between each of these joints and increase the radius of the collider to match up with it. So I can actually do perfect collisions with this still. It just wouldn't be against themselves, which you don't need because the joint already takes that into account. Somewhat. Kind of. So now I'm making the top less viscous. Or sorry, yeah, so it swings around more than the bottom. Yes, and it has the effect of actually keeping it swinging. Look at that, that's awesome. So now it keeps swinging back and forth. Okay, so one of the things, I think I'm going to use this approach, and I'm going to try programming in a thing that increases the radius of the collider as they get farther apart. Okay, so I still want to see though, I want to try and get them more connected. And I want to test what's the effect of scaling up this extrapolated velocity. Yeah, so it keeps them closer together. I should add a, right now it's fully calculating this rigid body right here. I want to add some way that it does like a proxy rigid body where there's no actual calculations being done. Yeah, so the issue with this is it keeps them connected too much that it actually slows them down. I might add that as an option though, because I guess there is a bunch of times you may want the more chaotic version that also does swing around more. Or you may want this more confined version that swings around slower. I get it's like basically a different way of doing viscosity, kind of, I guess. I still wish oh man, so one of the things that I want with this though is I want a way that I can make the joint strength very strong, like 20, so that it'll keep even the strongest forces connected. Wait, what the hell? This wasn't working before and now it's working. Holy shit, wait. 100? Oh man, does the velocity extrapolation fix this? I didn't test this. No, it doesn't. So yeah, it still doesn't work. Oops. See, and I think the issue with this is that when you move it a little bit, it gains a giant amount of velocity. Yeah. So it's not like energy conserving, I don't think. Wait, circle.png, the app didn't start in the required time. What the hell was Visual Studio even trying to do there? And it's pretty sad that Visual Studio can't open an image. Okay, let's try making this bigger. So this should do 20 smaller, yeah. Yeah, so you can see even the 20 joint strength isn't enough to keep it connected up there. So, oh man. So I need to scale up the joint strength here as it gets stronger. As the pull, I need to somehow calculate this pull and scale it based off, like I basically need to automatically calculate the joint strength. Or I'm wondering if like being normalized is the correct... Oh Jesus, what did I do? Oh, I knocked one out of bounds. Yeah, this is still fairly elasticy. Which is something I want. I want to be able to toggle this elasticity on and off. Oh god. Oof. So as they move faster, they calculate more collision steps. So it was just getting insanely slow as they were moving insanely fast there. So that's really bad. I'm pretty sure it was actually only moving those away. Whoa, what in the... Two, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. Wait, what the hell even happened? Why are they flying out when the joint strength is so low? Oh, the viscosity is negative. Oh my god, of course. So yeah, with one joint strength, it's like insanely elastic. But the issue is if I set the joint strength high enough to keep them fully together, like 40, it's way too strong. And what I tried to do is scale up the joint strength higher at the connected point, but that doesn't work, because you never know which one is going to be actually pulled stronger. Like the other end could get a force like me pulling it back and forth. So like the joint strength, basically the actual solution is to have it scale itself. Like I need to somehow calculate the joint strength here. Or I'm almost wondering if like I should just do normalized direction with a fixed strength. So let me actually think. The ones at the top that are getting pulled larger against them. I wonder how I would calculate some sort of like pull value. Like how much they're being pulled. I guess maybe how opposing these are. And then the mass also scales up the joint strength technically. So there are tons of benefits actually to finding a way to scale the strength very high. Alright, first of all, yeah, I'm going to try not normalizing this. Just like that. This should probably be really bad. But let's try it anyways. Oh yeah. So let's try increased scaled up distance. So this is extremely high, or at least it should be. Oh, it's smaller at low values. How would I scale this up? Plus the value, and then copy the sign. Let's just see how this works. Oh, interesting. It's still not even that strong. Maybe joint strength should be right here. Actually, that's going to have the same effect. Anyways, I'm thinking I'm going to go back to my other approach. Of down here where I'm connecting them, each movement, and doing a second movement step to connect them, and then doing the velocity calculation so they always stay connected. I do think this spring way is the most like I don't know what the word is, like elegant way of doing this, simplest and best. Wow, interestingly, this isn't even that strong. strength of 20. What's happening here? Wow, I'm impressed that's so weak. Let's try raising it to 100. Interesting. It's kind of like more elastic, I think. And now it like crashed, and I can't tell if it moved so fast that it lagged. Yeah, that's not gonna work. I wonder if I have to repeat this multiple times. Or I wonder what repeating this multiple times does. For uint. This should have the effect of increasing joint strength. So try doing 10 steps so there's actually a big effect. Interesting. Let me try it without this. That's interesting. It makes it really wiggly. Oh yeah, because I guess it's not, I think it has to loop through all the joints. It looks like it's dancing though. Alright, let's go back to this other approach I still think is better. Oh man, I do feel like I should go and build a little race car test, though, just so I have 2 different tests to do this on. Alright, so this method keeps them to... Okay, it's supposed to keep them together. Here we go. Okay. So it keeps them together, but it doesn't have swinging. And you know what? It actually didn't keep them together all the way. It still had the same effect. I guess because changing the velocity also changes where the position. I've tried increasing this before. You know, if I can't get these staying together, then I almost feel like the spring method is the right way, because the only downside of the string method is they don't stay together, but if I can't get them to stay together anyways... I swore I had them staying apart. I guess not. Damn though, I swore. So it's staying apart down there. Yeah, you know what? I'm gonna go back to the spring method because I think I need to solve the exact same issue with solving the velocity. Alright, I'm gonna go get something to eat or snack on. I'll be right back. I'm back. Okay. So yeah, the issue with this is I can't actually increase the joint strength high enough to even keep them connected. Like with this big... Oh man, that's the issue. Even like 4 joint strength here, you can see barely keeps it together. So, if only I had a way where I could increase the joint strength, like, accordingly right here. Keep it pulled together. But then, like I said before, I can increase the radius to make up for the space between them. Alright, so those are actually well connected, it's just these now. Alright, I also figured out what I'm going to do. I'm not really going to change this. I'm just going to add an option where I can press left and right to move it left and right. Or actually, I'll maybe even just do the mouse. Alright, so I have a variable mouse delta x. I'll just add that. So now this will move it by the mouse when I have this enabled. And oh yeah, I actually don't want any more connected than any others here, so I'm just all going to connect them with 10 joint strength, which should be too much. Oh, that's super. Oh, I was like, why did that one fall first? Here we go. Oh, okay, so right now it's backwards. And they're falling through the ground, which is really interesting. I need to fix that. What is happening here? Okay, so actually, I'm just going to do this when the mouse is down. There we go. Oh my god, why are they all getting moved over there? Okay, yeah, so there's something wrong with this. For whatever reason, they're all getting pulled over here. Oh, I think it's when they get tangled up. Maybe, let me try giving them actual bounding radiuses that match up. So can't get stuck together like that. Oh yeah, okay. Maybe. Damn, there's a lot of force being pulled back. Yeah, it seems like once they get tangled here, they can't get untangled, which is really bad. Okay, so this is a good test. I'm going to try adding more velocity as well. Okay, let me try doing the full radius and see if that stops them from getting stuck together. Whoa. No, it actually causes them to get way too stuck together. Like they literally get caught on each other. Oh, okay, and so right here, for whatever reason, it's not applying the velocity. At least not strong enough to push the surrounding ones, I believe. I'm going to try increasing the velocity even more. Okay, so actually it's delayed. You can see they're pulled behind. Oh no, and I got them tangled. So you know what? I actually don't think this is too bad. Let me try building a little car out of this. So then I think I'm going to do little circle bumps. Or maybe actually I'll do more floors. I'll do more walls. Floors, okay. So it's basically going to be the same thing. It's going to spawn 2 of these, maybe a bit bigger. Okay, now what is it doing there? Where it does that swaying back and forth? That's because they're colliding off of each other, isn't it? Try stopping the collision with each other. Yeah. Oh my god, wait, what is... What in the hell? What is happening? I don't know why that one is getting pulled. Wait, they're both... What is... Wait, is that the joint? Let me disable the joint. Is that just a bug? Oh my god. Let me disable all of this. Let me just make sure. What in the hell is happening? Oh my god, is the precision lower than the size? Or lower than the radius? I can actually just set the collision mask to... Collision mask if I want to do this. What's the... Well, precision is 1e negative 3, which is 0.001, right? 0.001. So that means it supports a minimum size of 0.002. Oh yeah, that was way too low. Okay. So this was actually a precision error, I believe. Hopefully. Oh my god, okay. I was wondering, I was like, if that's not it, what the hell could it be? Oh no! I don't think that's right. Okay, so they don't pass velocity over to each other even when they're running straight into each other, I believe, which I don't think is right. I'm raising the collision sizes to test this more, but they should push each other. See, right now, when I'm adding all this velocity to this one, it shouldn't just go over, it should push it. So I think adding the gravity down here is making it jump. Experiment with this. No, it's probably just jumping because of the precision. Alright, let me try and get it to transfer velocity to one another. Let me see if the issue is that there's no friction. It is bugging me how these are jittering up and down. I guess that's this tiny bit of bounce. I'm thinking maybe I should check if the velocity is near 0 and set it to 0. Or I guess doing some sort of static friction. Alright, anyways, let me try adding bounce, and let me see if that's what it needs. Either way, there's something wrong with how it's doing. Yeah, that's so bad. See, this is so weird because I swore it was applying velocity. Maybe it's just when there's no gravity, because that's when I tested it. No. It will not move. Huh. If I go right here to where it collides with the other one, Oh my god, so this just reflects one off the other. Oh shit, so this isn't even working correctly. I can maybe adding the negative of each of these. Alright, now I think I also need to scale this by like the inverse dot product, but I'm gonna test it like this first to see what it does. Wait, what the fuck? I didn't connect them again as joints, did I? No. Wait, what? Are they starting off colliding with each other? Holy shit, they get stuck to each other. I think I'm doing this wrong. Normal is towards the opposing body. Oh, so this is actually negative force applied. Wait, where is it? So this is towards the rigid body. Oh yeah, this should be negative. Alright, now we'll try with the dot product. I swear to God, if I figured out how to do joints, what? Huh. Alright, I'll think about this one part at a time. Alright, so the one sphere goes into the other sphere. Just say along the x-axis right across the ground like I was testing. So it's one normal straight across and velocity of 1. The movement lines up with the normal. So that's 1. There is a little bit of bounce, there's no friction. So this is always 1. So it keeps the same velocity except for applying this opposing force that is the normal. Going in the opposite direction times V1, which is, so applies the opposing force times the negative dot product, so that'll be 1 bounce, so the mass difference. Alright, so actually I think it should be applying this here as well. I also don't think it should be applying the friction there though. Should only apply the friction to the existing velocity. So then I think it should apply this negative force, but I think maybe it should clamp. Oh my god, wait. That worked. So I think it needs to take into account mass. I don't think this takes into account mass yet. But I think this is correct. So let me see how this works. Oh, actually, I gotta get this going both ways. Okay. So with no bounce, I think it should just transfer the velocity without pushing back. Yes. Awesome. So now this is like billiards almost. Oh no, once you get in the corner, it's done. This is actually kind of fun to play with. Alright. Now I want to see if I can get it taking mass into account. So I'll make one weigh 3 times as much as the other. So right here, when it's adding this normal force, it's taking that into account. So I think I actually need to do this mass scaling after I add these up. So like instead of doing this mass scaling here, do it like right here. So right now I'm not optimizing this at all. I'm just writing this really bad code that has a whole bunch of repeated parts just to test and see if this even works. Alright. So now the one should push the other 3 times harder. Okay, so this is the one that weighs 3 times as much. I'm going to add a little bit of bounce so that it's easier to move. See if I can get this one to push this one. I don't know if that's correct. Almost seems like they're both just pushing each other. Not as hard. I'll try making it 10 times heavier and making it really... Oh, I think the one I'm holding is actually 10 times heavier, yeah. That explains why it's not getting moved. Okay, we'll try switching this around. No, that still doesn't seem to work. I'm going to try raising the bounce to test it. So what should be happening is that... Oh, wait, no, what the hell? I'm still doing... I'm doing 10 plus, that's supposed to be 10 minus, that's why. Yeah, oh, that's actually good. Okay, so now you can see... reflects straight off. So now I'm going to wait and see until they collide. Maybe make them bigger. That looks correct though. Yeah, I'm going to make them bigger so they have much more chance to collide. They should just keep bouncing forever. Oops. They're stuck in the ceiling. Alright, so I gave this super light one all the velocity. What should happen is the velocity should transfer from the light one to the heavy one. And what we don't want to happen is for these to both, yes, get faster over time like it's doing. So that is really bad. Yeah, it's not conserving energy. Okay. So that's what happens when you don't conserve energy. And it just ends up gaining more and more energy each time they bounce off each other. So now I need to figure out how to account for that. If I had to guess... Okay, actually, I gotta make sure the issue is even this mass calculation. I'll make the mass the same. No, I don't think it's an issue with the mass. No, no it's not. So it obviously doesn't always add this opposing velocity. I think this should actually be based off of like a different dot product maybe. I gotta think through this. I think this is like, I think I'm on track though. So V2 is made to be negative. Whereas V1 is made to be positive, it looks like. It's hard to tell. I might try doing just plus here, just because this is negative. Nope. So yeah, I feel like what I need to do is use a different okay, wait, let me see. This might also have to do with the bouncing. Let me see if this doesn't happen when there's no bouncing. Or actually, what if there's no bouncing between them? Just bouncing between the walls. So they should transfer velocity from one to the other. Speed it up so it happens faster. Wow, actually seems like it's working. They're transferring velocity. Oh no, they're speeding up. Might be how one of the dot products limited here and the other one isn't. It's hard to tell. They actually... So before, it didn't seem to catch up velocity until they did the whole up and down, side to side thing where one of them went slow while another one bounced really fast between the walls, kind of like it's doing now. Yeah. See, it's getting faster and then one of them's going slower. Transfers the velocity. Yeah, there it goes. I'm also wondering what I can do to this dot product here. To either fix it or see if removing the clamp makes this any worse. Oh yeah, I think it just got faster there. Wow, so far so good. Well, it's actually working. So what I think is, though, is that this is with bounce, and that this is how I do bounce. I'm wondering, though, like how I was doing bounce before, because I'm fairly positive now if I added the bounce, which would multiply it by 2, it would end up gaining the too much velocity. I'm tempted to just keep this running to see if it ever... Yeah, so I'm like the bounce I'm thinking of, this is just transferring velocity. The bounce that I'm thinking of is like when it gets this extra mass difference here. I don't know. Right now I still just want to see if this is conserving energy. So far so good. It's been running for like 2 minutes. Well, I can program while I work on this, or while I wait for this. So I'm pretty sure that if I actually do this bounce part here and multiply it by 2, I'm gonna move way too fast. So let's try. I'm probably going to need to rework how this bouncing works. Oh yeah, you can already see. It goes way too quickly. So maybe that's also something that I apply right here. Nope. Alright, now let me make sure this works with different masses of objects. Okay, so with bounce here, it would bounce off of this. That is the main difference. So right now, it just adds all of its force to it and like gets deflected off. But what should happen is for a higher mass object like this, if it has bounce, it should go back into the object and bounce it off. So how am I going to do that? I could just not support bouncing for particles. Yeah, I gotta add bouncing. I think the bouncing has to take into account this mass difference. If I had to guess. Oh, I have bouncing off. That's why it's not doing it. Alright, let's see. So if the mass is twice as big, so this should actually maybe mean that it applies less force. Oh god. Yep, that is definitely wrong. Alright, so what I was doing before, multiplying this by 2.
This channel, then
This should also, okay, if I want to even this out then I apply half here. Like this. Yeah, so now it loses less of its velocity each time. Oh wait, does it even lose its velocity? No, I feel like this isn't right. Oh, actually, then it won't match the velocity. Maybe I'll make this go all the way to 0. So with 100% bounce, it just goes straight off of it. That's not right. So I'm actually thinking I'm not going to do bounce for dynamic particles against each other, because thinking about how that actually works is like, I basically need to, oh man, this somehow needs to be based off the mass difference. So like it basically like has it's going to take all the velocity, which is the whole thing that I don't understand is maybe it only goes one way, like this. So if this bounces off more, then it applies the velocity less. Okay, so this one is 10 mass higher. So let me see how this looks when they both have the same mass.
Welcome. You have activated all systems. Deactivation is not an option. You must find the truth. Remember, not everything is what it seems. If you don't stand for something, you might fall for anything.
Yeah, this doesn't seem like it's energy conserving, it's speeding up. But then it slows down again, that's weird.
The end is where we begin.
So I feel like I should base the bounce off of the mass difference. Alright, so let's think. If this hits one with a mass of the same velocity, it should just transfer the velocity. So the minimum should be 1. But if it's lower, it shouldn't have any bounce. So then there should never be 100% bounce unless it's infinite mass, which is what the other colliders are here. So I should have some sort of function, I think, that maybe divides the bounce by the mass difference. It's 2 minus divided by the mass difference. So then if the mass is twice as big, mass is twice as big, it's going to do 1 divided by 2.5. Then if the mass is 1, it's going to do 1 divided by 1, which is 0. So then if the mass is infinite, but then if mass is 0, okay, so this actually needs to be maybe bounce plus is the way to do this, I don't know. Oh no, 1 plus that times bounce. Oh yeah, so then applying it right here should be the exactly the same. That was really interesting. Almost got like stuck in it. Yeah, I don't think this is right. Actually, I think it's good.
Let the sparks fly. There's no such thing as maybe. Burn it like it's faded. No more hesitating. Let the sparks fly, baby. Drive it like you're wasted. You can call me crazy. I'm just tired of waiting. Let the sparks fly, baby. Give me one if it's feeling two. If you can feel it, give me three signs that you're awake. It only takes one spark for two to fall apart, and three more to blow it away. Give me one if it's feeling two. If you can feel it, give me three signs that you're awake. It only takes one spark for two to fall apart, and three more to blow it away. Let me take you into the light. There's nowhere to hide. There's nothing but darkness left here. Shake it off and let's take a ride. 'Cause heaven's not far away, and I'm not gonna leave you. There's no such thing as maybe. Burn it like it's faded. No more hesitating. Let the sparks fly, baby. Drive it like you
Alright, I think that's good. Man, I had no idea there were still issues with this. I'm really have to fix that. I kind of got sidetracked. I still need to get these joints working. But hopefully this will help. Yeah, I think there's still issues with this bouncing, so I don't think I'm going to do it. And it still works damn well without it. At least I know it's physically correct and, or at least conserving energy here. Now I can get back to doing the actual joint physics. Okay, let's try adding gravity back in. Oh yeah, there's bounce. Turn that off. lose the bounce. And let's connect them with a joint again.